Let me kick off a tweet here. Do 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 do. There we go. Uh-oh. Bad news from Twitch. Why does it say I'm incompatible? What's going on there? That all looks the same as it always does. Yeah. Yeah. Does it look weird? It says like this little. It's got this little message that says incompatible, but I don't know if that's a real problem or what the deal is. Maybe I should refresh to check, right? Okay, it looks better now. Guess it was out of date. Okay. Cool. So I released this update on my project yesterday, or early this morning actually, as it turns out. It's actually didn't get out until after midnight, but you know, it was supposed to be yesterday. And if you take a look at this, I described the basic characteristics of all four the buffers, if you didn't already know about them, what I anticipate to be the strong suits and drawbacks of each one, and now we're going to actually set up the test to see what happens in reality when I put timers on things and test them for correctness. So, this is a fun part of the experiment. I have to think about what's the best way to organize this before I do anything else, because basically what I've been doing is all of my buffer code just goes in this folder and then it gets moved out to this folder in order to push to the Git repo. And I'd kind of like to say that I continue to have it set up that way. So I'll just have a file in here that isn't got anything to do with 4coder. It'll just be like 4coder buffer test, right, .cbp, but it never gets compiled into 4coder. It'll be a separate build that I'll start running. So I guess it's got to set that up. November 6th. Okay. And this thing has to basically include everything that I've worked on so far. and we'll find out if all of these things are able to coexist, which I don't know yet. I also need something kind of like this, only now I don't include this at each stage. I don't need this part, or this part, or this part. It's just a matter of getting these 4 defines really, so that I can get abstract in there once under each define. So every time I define that, it changes how that abstract layer gets what that is defining. So each of those defines actually includes a different set of overloads for the same functions. Hello, Splinty98, welcome. So that's kind of cool, and hopefully that won't cause me any confusion as I work on this, but I don't think it will. Okay. And then finally I'm going to need a main in here. I'll probably just include some standard stuff here. I want it to be, this is not an appropriate kind of project to go platform dependent. I'll take the hit and have the dependencies because I'm just running this everywhere to measure stuff, not to be a super useful product, right? One minute. Okay. Alright, so what else do I need? I'm gonna need standard IO. And then I need I'm gonna need a way to keep time. And I don't know if there's a platform independent way to do that, which is kind of nuts, I think. C standard library time. Looks like there is a time header. Let's see. Converts TM object. Let me show you what I'm looking at. I don't know, this is Wikipedia, so who knows what this is actually talking about, but maybe this is what I think it is. Preprocessor tick count. Right. Time returns the current time of the system as since the epoch converts a TM object to a textual representation. Don't like that's deprecated. Okay, don't use that. I only want format conversions, clocks per second, number of processor clocks, clock ticks per second. Is that reliable? What's the deal there? Time since the epoch type. Div time. Okay, let me take a look at this function and see if it gives me how kind of resolution you get with this. Time t. Current calendar time encoded as time t object on success. On error. Epoch is not a null pointer. The return value. Okay. What is this time t type got in it? C standard is almost always an integral value, holding the number of seconds. Well, the number of seconds isn't very high resolution, so it sounds like there's not a high resolution standard way, or at least I haven't found one yet. We could keep looking. High resolution C standard time. High resolution time with C++. Yeah, it doesn't look like there's a high resolution standard timer. Okay, so we do platform specific timing still. What is the C preprocessor platform defines preprocessor macros? That's what I want. If def win32. Okay. Yeah, okay. Okay, so I'll do win32. That looks like, I wish I wasn't on Stack Overflow, to be honest. I want like a chart, a table of these things. Okay, here we go. This looks better. Maybe. Maybe this is better. I'm not sure. Win. Never mind. This is not what I want. Identify OS with preprocessor defines. Um. Let's see. Alright, so Win32, it looks like a pretty good option for checking for the Win32. So that's the one I will use. Timer not supported by platform. Alright, so now we just need a platform. Well, we need a windows.h. We need a nice way to measure time, so I'll probably do a type def there, so I can get like a long. I could even stand to make that unsigned. Do, 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 do. Um, time. Int. And then I want a simple function like getTime. Query performance counter time. Return time int time dot quad part. Hello, insofar as how's it going? Then the other thing I want to do is say when I return this, I need to like have a convert function or something. Alright, I need to query performance. I forget the name of this function too. Query performance. You have to do this. If you forget to do this and you think it's just going to give you your microseconds directly, you will be in a world of hurt. Yes, get system time precise as file conceptual. No. There's like another query performance function or query performance frequency. Here it is. Yes. I don't love calling this twice. Maybe what I actually want is more like a this situation. Huh. Huh. That doesn't even need to be a time int, but I guess it could be query performance frequency. What exactly do you output if the installed hardware supports a hardware the return value is non-zero? Point to a variable that receives the current performance frequency in counts per second. Okay. So what we need is like we'll do a time int. It's not totally appropriate in terms of units, which makes me not thrilled. I'll do this. Counts per second. And then when we do time init, it will do this. We'll have it return an int here for success or not. I could possibly stick to my original style. That would be possibly a good thing to do. time int large integer. If we get the query performance counter, so that'll return whether or not we actually have a timer that works, and we can like abort early if we don't get one. And let's see, we have the time come in, so then the counts per second can equal the quad part, right? Alright, let me set up a quick, let me set this up in my build. Slash code slash buffer slash 4coder test main dot cpp. We can output this to buffer test, and we'll pass in the rest of the flags that we need. Alright, let's see if that runs at all. See if that builds. Oop. So I have a few misnamed things sneaking in here. Also, if I go to 4coder test main, it's telling me it wishes that I would put this first so that it could grab onto those definitions that it needs. Right, it also wants to see assert up here. It probably wants to see string up here. Yep, forgot to add scratch memory to this one, apparently. I thought I added scratch memory to all of these, but maybe I didn't. Alright, so now we should deal with the fact that I need to define all of these things real quick. So that will be in shared up at the top. Let's see, it doesn't know about my... It's not so happy about my seal, so I'll define that. Ceiling of a float is basically... I'll just take a look at how I did it before. I don't recall at the moment. Don't feel like figuring it out again. Where does this live? Does it go to math now? Yep. Okay. So it looks like I need this one. I'll put this into the style for this. Okay. I think I'll need this one. Getting a proper ceiling is kind of difficult when you want negatives to go have a ceiling as well. If I wanted just like a ceiling for positive only, it could be a lot easier. But when you consider that you might need positive and negative, rounding in one direction becomes a pain because you know the primitive always rounds, always truncates. So you don't have like a round that goes in the same direction. If you had one round that always went down, for example, then it'd be easier to make a ceiling from that. You would just negate round and then negate again. But alright, so div will be seal. I love how much Emacs freaks out when you have a build that isn't at the right level. Okay, we need round out. Those will actually don't need to be defined. So, because the other one will get them. So let me go back to math. Round up. Okay, let's see. This needs unsigned int. X is not equal. Alright. So that passes a lot of that stuff now. Edit step. Batch edit. Yeah, this is kind of gone. We're not using that. All of this stuff can go about the scalpel. Everything is implemented now. so that needs to be non-abstract, what is going on here? Can I convert one from gap? Buffer cursor seek. Cursor position buffer type is gap buffer. Cursor seek has been defined with the gap buffer. Cannot convert argument 1 from gap buffer pointer to buffer pointer. Yeah, but why don't you have an overload for that? Cursor seek step is not the problem. Oh, this shouldn't be inside of the non-abstract section. That can be non-abstract. There we go. So that's not so bad. I still think that was easier than dealing with templates to get my sort of generic layer working, or at least building, I should say. And now I've got a timer. Let's see if we have a working program on our hands yet. I'll start with just making sure that everything is sanitary and running. Oh, I don't have a run script for this yet. Let me add that in. What should I call this one? Run experiment. Oops, there we go. What did I call this? Build all. Test. Buffer test. Okay. So run experiment. Hello, tests. Okay. Let's see if I can time something and see if it makes a little bit of sense. So to get everything kicked off, what I need to do is run a quick time init. And we'll say, look, if time init, if not time init, then return, what we can use exit, actually, it's even better, exit 1. Okay, so try to init the time right away, and then what I'll do is I'll set up a test loop. I is less than 100,000 plus plus I, j plus equals I bit shifted down twice. I'll introduce a couple of variables. And then what we do is we'll have a time int t equals get time t equals get time time start, time end, maybe? How do I want to set this up? I want a way where... Yeah, that seems actually like a good idea. Okay, time start, time end. Now, what's the number I have, the thing I have to use to printf a... Well, what I could do is just say %d here. Microseconds. Right, and so we'll find j, and then to get the microseconds, it's 10 minus start divided by get time. Well, I'll just have those returned in microseconds, and then all I have to do is cast it to an int. And so what this will do is whenever it gets that result, it'll say result, and then divide that by result. Well, result equals result divided by counts per second. That would give me how many, this is how many counts, right? Result right here is how many counts. If I divide by counts per second, I would get how many seconds I want. Or that I have, but I don't really care about seconds. So what I want to do is also take that number and multiply by 1 million, 1, 2, 3, 1, 2, 3, so I can get microseconds. And what I should do here is say if int resolution if resolution is less than 1 million, 1, 2, 3, 1, 2, 3, then printf warning timer is not actually at high enough resolution for good measurements. And then time init will have to output an int pointer resolution. And so resolution is basically counts per second, exactly, in this case. Now, I don't actually know that that's actually what the resolution is. Like, that's the resolution. I don't know if it counts single counts correctly or not, right? It might count, that might be how many counts there are per second, but query performance counter might only give you every, 1024 counts or something, right? It might not actually give you counts at that resolution. So to be absolutely sure, I should look into that maybe. Query performance counter. Variable receives the current return remarks for more information. Less than 1 microsecond timestamp. Actually, when I say microsecond, I don't mean microsecond, I mean millisecond. I should be more careful with my metric system. I'm all over the place here today. There we go. What is the resolution of this? It doesn't really say. I wish it would say, the installed hardware doesn't sort a high resolution performance counter. Counts per a pointer to the variable that receives the current performance counter frequency in counts per second. Is the resolution of the counter in single counts though? Doesn't look like anyone cares about that detail, so I can't find anything about it, but I'll just have to assume that this is correct, and if we get really weird results or something, we'll ask otherwise. But I think that we'll say that's as good as I can know about how good the resolution is. All right. Apparently I'm doing brackets around these. I still don't like it. I do not like it for those two. Okay, that looks more my speed. Alright, so yeah, that's good. Okay. Next thing I need is to run it again. So let's see if it builds. Got an issue. Right. Time int is for measuring microseconds, right? I want this type to mean microseconds, so do I want to introduce a sort of resolution name for that type instead of typing unsigned long everywhere? I don't know. I never know. I never know what to do with this stuff. Alright, there we go. Yeah, I don't like having that floating around. It's kind of annoying. .266 microseconds. Okay. Let's see if that's scaling properly. It's about 10 times slower. And it's about 10 times slower again. Alright, so that's pretty cool. That's pretty cool. The Windows timer is up and running. Okay. So next up, I want to one thing I want to do, there's two goals. For one thing, the tester should do a correctness test, and it should then do a speed test. On all 4 buffer types, across the way. And what it could do is do a time test and correctness test together, where it times the thing it's doing and then checks them for correctness after having done the timing. But I don't know. I don't see any reason why not to do it that way for now. Maybe I want to separate them so that the correctness test doesn't take as long, but I don't want the time test to take forever either. I want it to be enough to separate them out, though. I think doing them together just makes it faster either way, so I'll do it that way. Yeah, thought so. Alright, so that means next thing I need to do is get a file. And what I'm sort of tempted to do is say, like, there's a setup function here which will pull this stuff out, and this, and this, and it will well, maybe not that, because we probably need to do more than one file over the lifetime of the test anyway, so we'll do that. We'll run the setup, and then, though I don't have to have that resolution variable sitting there annoying me, I'll do an fopen on, I'll need some test file 1, read binary, okay, and then at that point I probably want to introduce I have a feeling like in this file I just want to do a slightly less strict style than what I was doing in the others. Don't totally know why, but it just sort of where this is going. So then the file data is like a get file function that takes in a file name, and that just has to do like result.size. Oh, I need to. Okay, so actually this does come out, which means I can rename this to file, which was kind of one of the reasons I wanted to do this in the first place anyway. So I get the file name right here. File. So that opens. If we got file, or if we did not get a file, I'll just okay. Then I need to do some fseek stuff, which I always screw up. Fseek, I can't remember which parameter comes first and which comes second. Or which comes second and third. Like, I know the first one is the file, but I don't remember after that if I need offset or origin. So seek set goes last. Okay. Then I need to read in. Wait, I need to malloc some stuff. So the result data equals malloc result size. fread in. How does fread go? There's your stream. Okay. That's a kind of weird way to name the variables, whatever I was just reading, but that's okay. I get the idea. Let's see. Yep, that's a pretty good looking get file. I'll throw in a free file function. So I'll probably want that at some point, just for niceness. Are you asking me if I'm learning right now? I mean, no, I'm just sort of setting up some basic stuff to get this thing going, right? Alright, so next up I need, I'll need one of each of my buffers up here, so we'll have like buffer, gap buffer, um, multi-gap buffer, multi-gap buffer, and the rope buffer. Okay, so now what I can do is step one, initialize. I gotta time initializing all of these things. And what I'll kind of want as I go is like a concept of time record, which is like these four guys. But just the times of each one. Let's see, that's init time. Okay, and then the next thing I want to do is, let's see, file init time. Maybe I start it. Yeah, whatever. Maybe I just start going. So t start equals get time. T end equals get time, and then init time equals init time dot buffer equals t start minus t end, and for each one of these things, how does 4coder normally convert these guys in? So and init, for example. We have an init type. Yeah, so I'm going to use declare anywhere for this portion. Okay. Init type does the allocation and buffer begin init val string val dot size buffer end init. So is it somewhere else that the convert in happens? The convert in has to happen at some point. Okay. Does the same thing happen with the rope? No. What about with the gap buffer? Yeah, the gap buffer converts in. What about the multi-gap buffer? Alright, so I just forgot when I was working on ropes that I needed to work on uh-oh. Yeah, I don't care about this right now. that I needed to work on getting I need to test the convert in, and I guess I accidentally saved over my test with a conversion already finished, so I need to open it somewhere else and see the result. What about this? I don't see any /r's there. That could be getting converted in before it gets fed as input, I think. So let that finish out and then I'll kill it. Basic.txt. There it is. Okay, so yeah, the rope is not converting in. What do you know? So let me take care of that real quick. Here it is. Okay, so right here is where we're taking some string plus read position, increasing that, and then what I want to do is I want to do like a convert in, so it's more like look at what the gap buffer does, for example. And yeah, okay, so the node's weight becomes the convert in of the destination goes here, same exact source, and a size. Okay. That's good. That's a good catch. So that's nice to have fixed. Okay. So that means that for the initialization, all I have to do is kind of like this with the loop. So it's like for the first one, for example, init. How does buffer init type get it defined? Golden array, buffer init. Yep, that's what it's called. Okay, so we have this init. Probably clear it to 0 to begin with, and we say begin the init for the buffer. Oh, I don't need to clear that to 0. I need to set it to the result of this. Gotcha. The data is the file data, and the file size goes there. Okay, so that begins an init. And basically, it's a for loop, right? So we begin the init while init need more. Find out what page size we need. Buffer init page size. From the this requires the init. Hello, Canuckles. How's it going? So that gets us a page size, and then I can do the required malloc. And pass that into the provide page function with the init pointer, page, and page size. When the whole thing is done, I have to call end init, and I want to test that it actually comes through, right? So assert the result, and this is just I pass in the init pointer, and it wants some scratch size, so I'll have a scratch that I float around that'll be plenty big for that purpose. Alright, so that measures setting up the buffer, and afterwards we'll have that buffer initialized to that file. So let's do the same thing for every type of buffer now. And this is where it's going to get annoying because I'm going to have the same thing pasted 4 times. You could consider doing a template there. You know, I'll give it a shot. I'm hesitant about the idea, but I like to give it a shot. So, buffer type. We'll go here. And I'll have to tell it it's a init type too. Init buffer init type, and this will be like the void init buffer. I'm not super excited about this, but if it doesn't make too much of a hassle, this might be a win in this case, so it's worth a shot. This is going to need access to the file data, and the scratch, and the scratch size. It's been a long time since I've typed in the word template. I'm not sure what will happen now to any of us. Okay, this program that I'm working on, Hello Melting Java, what this program is set up to do is I've been doing some experiments with a text engine, and if you go to my blog here, there's several posts about starting it, what I was working on. I made an update here, and then here is what I just posted yesterday, or if you measure it correctly, just barely this morning, about these 4 different types of text buffers that I have been working on, because I want to measure how well they do on my first pass. Like, I take a first pass at each type. I want to see which ones perform well under which problems in reality, right? Put some actual numbers on it. So this is basically an experiment to measure them and also to test them. So like if I have 4 different data structures and I make sure that they're all working correctly by comparing their results against each other, that provides a nice regression test. Even if I end up going with something simple like the gap buffer or the golden array, it works as a regression test too. So this is to test correctness and speed of these 4 things that I've built. And in addition to that, it's all public domain open source stuff, so you can check it out at this GitHub repository where I have the 4 buffer types up there, the golden array, the gap buffer, multi-gap buffer, and the ropes, as well as some other code that they need. And right now I'm setting up this test harness, which will also show up in this repository tonight. So I'll post this link in the chat in case you are interested. Okay, yeah. So what I was doing was I was saying maybe I want all of this code here in a template because I'm gonna have it repeated 4 times and it's all gonna be nearly identical. Alright, so this takes the buffer, the file, the scratch, and the scratch size. And, so now the only code that's being duplicated is all of this. These 4 lines. Times start, end, and record. I'm not sure that it will get much better than that, so I'm just gonna go with it. I mean, I could put the timers into the template and then it'd get messy. I wouldn't like that. I wouldn't like that. This is the right way to handle it. Multi-gap buffer. And, you know what? It won't be able to induce that type, which is a gigantic pain in the ass. I'll have to go back and fix that rope buffer. Alright, so what I actually need to do for a little template cleverness here, this type here is deducible and this one isn't, so put this one first so you can specify only that one. And this is buffer init. Gap buffer init. Multi-gap buffer init. And rope buffer init. Okay. Keep hitting my mic, sorry. Why would any of that be illegal? I mean, I've included my rope buffer up here, right? Buffer type. I wonder if down here, oh, you know what I have to do is undef this one more time. Should undef that. Right now my compiler is the Microsoft Visual Studio compiler. I'm gonna try to make it compile on my Linux laptop, hopefully today or tomorrow, sometime soon. So it should run on GCC and everything. Like, I'm gonna try to make it run everywhere because I want to test it on various compilers, various platforms, various computers, all that good stuff. Buffer init type. Buffer stringify type, buffer backify type. I'm going to take all of those out. Test. Buffer init type, illegal type for non-type template parameter. I still don't know what it... Okay, I mean, I kind of know maybe what it's doing. Okay, so one thing I could do real quick is... Maybe I brought this difficulty upon myself by mixing macro style generics with template style generics. Maybe that's the reason it's difficult in this particular case. It might also be that it doesn't like using struct in the template. I could switch to type name. I think it used to allow that, but we'll see. What do you know? That's... wow. Okay, that's pretty much the craziest thing ever. Now, what are we talking about? What am I talking about? Type def, type name. It accepts type def, but not type name. Maybe it was just a different error. Okay, the fact that it has so wildly changed all of those times that I did put something in there differently is kind of nuts, right? Kind of nuts. Okay. Rope buffer. Unreferenced local variable. Well, that's because I haven't gone and finished my work. It's not your fault. It's mine. Don't get mad at yourself. Compiler. I was not clear about what I was talking about. Oh my gosh. It's also lovely that Emacs is being ridiculous. Buffer pointer. No, I don't need a buffer pointer. Okay. So that's not the worst possible thing. Now what I could do alternatively is to introduce a new file that it works kind of like the abstract file that I just used the macro generics for. But I don't know. If next time I do a template it's just as much of a hassle as this time, maybe I'll think about it, because that was probably more work than I ever did on getting the macro generics to work. So I'm using free instead of delete because I'm using malloc instead of new. That's why. You can't delete something you malloc. Okay. Dot dot dot. Yes, cd dot dot dot. What does that do? Nothing. Cool. I want to run the experiment. Alright. Now what we need is I need to look at my debug batch. Debug experiment. Okay, so I'm going to shut this down because I don't really need that sitting around anymore. And instead, I'd like to debug the experiment, see where it goes wrong. It may be a matter... Wait, why would it... I'm pretty confused right now, because it should have just exited for not being able to find this file, like, first and foremost. Well, we'll see. Would we have some kind of, like, unhandled exception going on here? Oh god, I should just take over the entry point myself, because I so don't want to deal with this. What's going on? like it called in already to my program. Okay. What? Um. So wait, if there's not a file with this name, it can still return a valid handle? What's going on there? What's that about? Can it's Oh, I wrote right binary. Why did I do that? Okay. Still not making it. So, what's going on? Gets this far. It still managed to open a file that doesn't exist for reading. I assume it's going to be like an empty file, but shouldn't that... Can't you just check if, like, not file... What? What is happening? Oh, I see, I see. Da da da. Da 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 da. There it is. There we go. There we go. Alright, so now that we're done goofing around, let's do something that makes a little bit of sense, okay? If that comes out as 0, wait, it still thinks the file exists? Why is that? It should be gone now, right? Uh, why is this behaving so strangely? It should be failing right here if I understand correctly. I mean, since when does this return a valid handle if the file doesn't exist is my question. Like, that's doing what it should do. Could not find file. So why was this not doing that? Oh, I bet you I've run it in here and got the empty file here too. Da, 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 da. Run experiment. Test file was empty. No, I didn't, because I didn't ever talk about the Emacs problem I was having. Emacs, when you use the compile it in Emacs thing, fi if your if the main target if the target file of the compilation unit that produces errors isn't like in the exact folder I want, it gets kind of weird and janky. Okay, so what happens when I run experiment? Why is that happening? Run experiment. So there's one in data, is what that is saying. There's one floating around in data now. Yes. There we go. Now I'm getting the behavior that I want. Now what I want to do is I want to go back to, whoops. That's a problem. That's a pretty big fucking problem. Um, well, we've got some good news though. Let me just save. I know there's one thing I've changed, which was the file view. I will write this out here for now. Forward file view.cpp. Alright, any others that I got floating around that I just recently changed? The buffers should all be fine. Math. I can save that one. It was not changed, okay. I've got handmade stuff open. It's a little unusual. I guess I haven't closed Emacs in a while. 32 handmade. Write this out. Oh wait, no, I don't need to save handmade. What am I doing? Keep going. String. Debug view. I haven't touched this at all today, so that shouldn't be a problem. System, layout, color view, style, forward, CPP. Yeah, I don't think I really touched anything else today since I first opened all these files. So now all I have to do is learn how to actually restore a Git repository, because everything else is stored in the repo just for scenarios like this. Will checkout be the thing I need now that you have that last commit? Repository at the commit before the file was deleted. Get checkout. I don't want to do name of file because, like, I don't want to do one file at a time because I want to do the whole directory at once, basically. I haven't made that many changes to things. Like, what I can do is pretty straightforward here. All of the code that I need to save is right here, so I'll just, like, store a backup right here for a sec. Then I just need to do git checkout, and I want to, like, check out the whole thing. So git minus minus dot will work. Okay. Haha. And now I just need to copy back in those two files that had the new stuff in it. In them. Boom. Yes. Move and replace all of that. And then in here, move and replace that. Alright, let's see if if git saved the day or not. 4coder lives on. So, it's a good thing I went to a nightly check-in policy. Alright, so that was a bit dumb. Back to the data. Was what I was trying to do. I hit up, and I thought that would be the thing that would take me back to the data, but it was actually the thing that cleared out all the CPP files. So that was a little bit of a faux pas. But now we're back on track. We can make a buffer test directory, and I can run run experiment. Should run in the buffer test folder. And if I switch CD over to the buffer test folder, there I can fill up, it should be, right? Okay, I want to fill that up with useful things for testing. So I suppose what I should do is step back one, I think under test, right? I have a thing. Test large.cpp. Gotcha. So I want to copy test/test large.cpp to buffer test file1.cpp. Alright, now we have a nice big 10 megabyte file. We'll see how everyone does on the various things I want to measure. So let me just make sure, I just built this, so run, let me to code now, run experiment. File. What? Alright, let's take a look. Old breakpoints be gone. You hang out. You get big. Okay. Right, I have to set this thing up to know about the correct directory too. Data, buffer test. we had a problem. Alright, so let me do that again and see what might have gone wrong there. So we have data, we have size, and it's gigantic, right? Almost 10 megabytes to be precise. Almost. Okay. And then the question is, do you need more memory? It said no. Why would it say no? It should have said yes. Oh, I know. I know. Do you know? Because I got it. I have it down. We need to tell it right off the bat that the buffer should be cleared to 0. Gap buffer and the golden array both worked. Multi-gap buffer, how does it go? This one takes a while because it's got to allocate a lot of pages to store everything in, but it passes nonetheless. So it's you who fails, and I'll bet you it's because your scratch memory is too small, isn't it? The scratch memory is too small for this gigantic file that I'm asking you to load, and so you are freaking out. I'm gonna just call it now, that's what's happening. But let's walk through and see. Yep, you got a lot to do there. That's fine. Let's get down to the bottom. Right now, we're going to find out if result should be 1 or 0. Why did we say result equals 1 there if we're just going to set it here? But anyway, we come in here, and there's still this scratch size floating around, and result is fine. Okay. So the question is, do we ever hit this situation or this situation? Well, if we ran out of scratch memory, it would have asserted, so that was just wrong. Aha! We hit this situation. It went to allocate a rope node and didn't get one. Didn't get one. Interesting. Interesting. Obviously the buffer has a gigantic node count. So what is it? 131,000 nodes. And not a single free node left. Okay. So what tripped you up that didn't trip you up in the past? Well, I've always rounded up. Maybe the roundup was helping before, but wasn't helping this time. Let's take a look at the very beginning. Free rope node, alloc rope, no, 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 oh no, oh no. Yes, this one right here. Okay, we get this far. We're trying to initialize this gigantic thing. We take the div ceiling such that we know how many nodes we need. We need 30. It thinks, okay, but it's not done. It's not done yet. How many of these do we need? It says round that up to a power of 2. Okay, so 39,000 up to 65,000. It says we're going to need 65,536 strings to hold all of this. Okay. Then it goes, okay, if you double that, and subtract 1, you'll find out how many nodes you'll need. 131, 71. Yeah, that's all fine and good, but I need an extra node in a certain circumstance. But it seems like I should have gotten more than 131,071 nodes thanks to the roundup anyway. I mean, obviously I should take the -1 out, but eh, 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 heh, heh. Here it is, ending it. Boom. Wow, it got exactly the node count it asked for. Well, that explains it, and if I take away the -1 in the rope buffer, node count equals, oops, yep, take away that -1 because we actually have an extra, we have basically 2 roots, not 1, so we need 1 more node than I thought. Now it requests that with a 2. When it gets rounded up, it'll have more. Let's go into the endinit function. How many nodes does it end up with? Ends up with 1 more than before. See if we get here. Result is a 1 now. Yep, we were off by 1 node. We needed 1 more node than we got. Alright. So bug caught, and now we're done running it in the debugger. We should be able to run it from here. Of course, I'm not actually printing anything out. So the thing I need to do now is in here, I want a concept of print record, which takes in a time record, and it'll print them out. We'll call this golden array. Gap buffer, multi-gap buffer, and the rope buffer. And I'll pop them in one at a time. Gap buffer, multi-gap buffer, and rope buffer. Okay. I want to do the formatting stuff. Don't really know how that works very often. So let's take a look at printf. I'm interested in like printf with you know, with I don't know. I'll just look and see if I can get a good explanation. Yes, yes, yes. Actually, first of all, I should figure out, I don't really want to have to cast all those to normal ints if I don't have to. Is there a way to do is unsigned? We convert it to an unsigned decimal format, the type DDDD, the precision specifies long. Alright, so first of all, these should all be ULLs instead of Ds. And down, oh wait, no, I'm not doing that one anymore. Right, okay. So ULLs, now how do I do the thing where it like specifies to line them all up at the same, like, so that their one's position is the same on all of them, basically. How do I do that column stuff? Like I want to say, tip from insofar as says 40 UL. Now the question is, does that pad them all at the same location or not? I don't think it would, because like the names still have to be the same length for that to work, right? Like if I run this, nothing will happen because I'm not printing my record. Yeah, so that's not quite right because I need, so what I need to do is like make sure that these strings here are behaved correctly, which I guess I could do with just like %s and then saying, hey, give these 20 each, right? So then I'll just put the strings in directly myself later. And then it's like, okay, this first one here is the buffer. The second one is the gap buffer. The third one is the multi-gap buffer. And the fourth one is the rope buffer. I don't know if that's actually allowed with strings, but I'm gonna just, cross my fingers and hope they did something reasonable there. Not bad, not bad. I'd rather the words here be left justified. Is there a way to say I want to pad something but make it left justified? I think these need to be LUUs actually. Or LLUs. Yep, that looks better. I mean, obviously those numbers are absurd. Another tip from insofar as says -20 will left justify. Fair enough. I'm good with that result. Let me shrink these down to like, looks like I could spare like 4. And these 40s are pretty big. Let's try 25s. Alright, cool. Now, it looks kind of silly doing a colon there, so I'll go with the dash instead. I want this to be just right so that it doesn't annoy me after I'm done setting it up. And that seems okay. Yeah, alright, I like this. So now the question is, why are the numbers looking like they're not doing the subtraction? Oh, t start minus t end is wrong, for one thing, at least. T start minus t end becomes t end minus t start. There we go. They all seem to be getting about the same range there. Obviously, I'd have to do something like run this a bunch of times to get a good distribution, because they're wiggling a lot. So let's work on that. If I have one thing here which is a record, another thing I need is a test statistics thing, sort of thing, or record statistics, which involves one time record of max and one of min. It involves one time record of like expected value would be the most useful one, I think. And then what I would do is I would say that I have a function that goes like get record statistics, record statistics, stats, time records, records, int count. Stats equals, well, stats dot max equals 0. Stats dot min equals min dot, well, min, we'll just say, how about we just say these all go to records 0 to begin with. Records expected, and then there's a loop across the rest of them, so there has to be at least one for that to work. At the very end, we can write this out like so. And to do the rest of my work, what I do is I just say, alright, for each one of these, we're looking at a particular record, so I'll get a time record equals records plus 1 plus on the record. If the records, first of all, take all of the expected fields and add in records or record buff, the equivalent field, gap, multi-gap, and rope. Oops. And then stats min dot buffer can equal the I'll make a little macro that's called minify, which will take this and this 34 gap gap multi-gap multi-gap rope rope, and the minify goes like this: if A is less than B, A equals B. And of course, being a good, responsible macro writer, I will make sure that I put everything in parentheses, just in case anything goes weird. Okay. So we can minify those. We're going to want to maxify as well. Actually, minify would go like this: if A is greater than B, A equals B. If A is less than B, is maxified. Right, so we minify all of these, and then we maxify all of these. And to change it now, all I have to do is say change min to max. That changes everything. And yeah, that should do everything I need it to do. Okay, so now I can collect some stats, which is fun, and do a loop on this section here, so it's more like init record 100 for int I equals 0, I is less than 100, or yeah, 100 plus plus I each step of the way. I write into the I part of the array as I finish the test, and then afterwards I'll have to spend a little bit more time to do freeing of all of this memory so that I can do it again. So it's like free buffer dot data, free gap buffer data, rope buffer. I can free its data and its nodes to get rid of everything that it has. Then the hardest one is the multi-gap buffer, which requires actually a loop. Multi-gap buffer dot chunk alloct plus plus j free multi-gap buffer dot we'll skip this on the last step so that they all stay initialized, by the way. I just thought of that. And the, let's see, the gaps, fixed width gap buffer. Yep, so I can just do dot gaps, j dot data, free all of those, and then when all of that is done, free the gaps array itself. Whoops. There we go. So that'll free everything every time except for the last time. What I should do soon is put in my own memory functions so that I can track so I can track all my allocs and pre's, make sure that there aren't any leaks in anything in my test. Print record. Right, can't call it on that. So what I need to do after this is I need to do get record statistics. Which looks like this. I need init times stats. I need that to go here. Init times stats. I have the init time and 100 is the count on that. And then what I will do is say init times stats dot average printf averages or that should be expected max min max min. Okay. And let's see, init times stats, init 100. Yeah, I don't like that 100 floating around. It's in 3 spots now, so we'll say like test repetitions is 100, and instead of writing that everywhere, I just know how many times I write the test. Alright. Boom. This might take a while. Let's see. Well, I can predict how long it will take. Before, it was taking 2 milliseconds to do the whole thing, right? Because those are in microseconds, which I should label, I should say US afterwards, but anyway. Oh, done. What do we got here? So the best min was achieved by the buffer, and then the gap buffer, and then the multi-gap buffer, and then the rope buffer. The worst max was occurred for the multi-gap buffer, and then the rope buffer, and gap buffer and buffer were right next to each other. That should say golden array, not buffer. But okay, and then this right here would suggest that the golden array was the fastest to initialize, followed shortly by the gap buffer, and yeah, so that's kind of what I would expect to see for initialization time, just because each one of these is sort of increasing in complexity. The thing that's surprising is this, but who knows, that could just be an anomaly, so that's why we have the averaged. So that's pretty cool. And now just the thing we got to do is I got to run this a second time to see if I have to actually make sure that the results are somewhat stable. Yeah, obviously the min and max might not be the same every time, but because if anomalies happen on a rare occasion, then maybe the big one will jump somewhere else, or the small one will show up somewhere else. But hopefully the average will be about the same as it was last time. Also, while this is running, I'm taking a quick bathroom break. Alright, we've got new numbers. Let's see. Looks like, as I said, the max did jump to a different location, so that's just sort of an anomaly that can sort of be ignored, maybe. But the trend is definitely the same. 48,000 versus 50,000, 52,000 versus 52,000. So there's about 2,000 in the average values. There's about 2,000 microseconds of variability between one run and another. The mins are about the same. Yep. All right. So there we go. We have a nice little test system up and running. So now all we have to do is come up with tests to run, and then we can measure them and pull the data out. This first one here measures init time, so I'm going to pull that into a function, but it's just bugging me a little bit, so I'm going to go fix this. Also, yeah, the golden array, the just flat array, it totally won that one. So that means, you know, all these cool data structures, what are they worth? Well, the thing is, this is initializing, and that's the strong suit of that array, right? That's the thing that I was expecting. That and iterating across the data are the two things that will be best at. We'll see when we go to test other things what else we find out. Who's really gonna win that? So this right here is kind of a useful function that I'll keep. So that's like void print statistics, record statistics, stats. We'll pass that in as a pointer because it's a big one. And then I'll grab all of these. You know, I could even just go so far as to say I just grab all of these, and I don't even ever, in the actual thing, ever create one of these structs. Time record records int count stats. Records count. This should here be stats out, not pit out, and init. Whoops! God! Emacs and I got into a little fight just now. I'm sorry about fighting on stream with my editor. It happens from time to time. Init time stats just becomes stats. And then at the very bottom it'll say, look, if stats out, then write that out in case you happen to want it. Alright, so now I have a way of just printing these things, and then maybe later I can save a bunch of the stats all at once and just dump them to a file if I also want that. Okay. So that's good. Let me pop down here and print statistics init time test repetitions. Oh, that's not going to compile. I forgot to put, we don't have a default parameter for that, so I got to put the 0 in still. Cool. And then all of this work here is, you know, I should also do is say when I'm printing this, I'll print out samples d count, and that can also be stored in the record as well for like if I'm dumping to a file. Count get statistics stats dot count equals count. Alright. Alright, so now I can say that we've got our first test set up and pulled out. This will go with it. So we want to do, and the test repetitions will just be a parameter I pass in. Void initialization test. And that should take like the buffer set, if you will, which is all of these guys. That'll take a buffer set. It will take, and we need a buffer set here. It will take a file, so that's a file data file thing. It will take scratch and scratch size. And then it can optionally output record statistics stats out. And the other thing I want is void test repetitions. Right, okay. So now I can grab all of this junk, drop it right, whoops, drop it right here. Close. Ew, 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 ew. That's right, I can't do that. So what I'll do instead is I'll say that time record pointer is just time record scratch equals init time plus test repetitions. And I'll want to assert that test repetitions times the size of one of these guys is less than scratch size. And if so, we're fine. And I take that and I subtract out all of this. Right, so now I need to say boom, 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 and boom. Boom, 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 boom. Initialization test. Let me pull up the test file over here. Initialization. So we have the buffers, the file, 100 repetitions, the scratch memory, the scratch size, and no output for statistics right now, except for through the screen. Alright, I'm hoping to see that that doesn't affect its performance. and that everything still works. Yep, still kind of showing in the average about 2,000 milliseconds of variability. We got a spike on rope buffer again. So that's interesting. The mins are also pretty stable, actually. Like, min seems like maybe not a... I mean, it's not necessarily the great way to measure because you don't want to say, like, you don't want to count on the best case scenario, but the fact that it's stable means it's maybe a good way to compare them, right? Okay. So initialization. Now, there's one thing we can do that'll be a little bit fun that we're not doing right now, and that's to build optimizations on. And, you know, while I'm at it, what I should really do is also assert, right, so what I want to do is say, look, if, oh, $249. Right, because I only need that if I'm in debug. So I need to conditionally declare that if I'm in debug. Okay. Now let's run the experiment with some properly optimized code and see if the distribution changes at all. See if we get real world numbers here. Actually, we won't see if we will. We will. We'll get the numbers that happen in the real world. We'll just see what they are. Alright, so yeah, the initialization, I think that just caused the golden array to pull away even more from the pack in terms of speed at initialization time. It's pretty much across the board now. The only one who is kind of interesting is that the max on these two doesn't always seem to be stable, which is interesting. And I'm not totally sure why that would be, right? But my guess is it's because multi-gap buffer does more allocations. And so maybe if it gets itself into a bad memory state, then it ends up spiking, but otherwise it doesn't do as poorly as this one, right? So like out of 100, maybe there's a good chance that it spikes once, but it doesn't always. Because this hasn't always been greater than that, but we should run again just to see, because maybe now that will behave the same way every time or something, right? It'll be closer to being the same as it was in this run. You can see that the worst time for the golden array was actually worse than the worst time for the gap buffer. So I'm not sure how how interesting max really is. Max sort of seems to be more of a measure of variability, right? It sort of shows how much variableness there is because it randomly spikes upwards. Yep. So that time everything sort of flip-flopped, and now this guy has the lowest max, which he didn't have before. It was actually the gap buffer, and the rope has the worst max. And so there you go. But the other numbers are only varying by about, there's about 1,000 on those two. There's about 1,000 on those two. It's 500. Yeah, so they're varying on the average by about 1,000 microseconds. Which reminds me, let me go add in my label. Right, %d microseconds. Okay. Alright, so that's a pretty good first stream. I'm gonna cycle the recording, take like a 10-15 minute break to maybe 30 minutes because I'm kind of hungry, but I'm gonna come back and we're gonna test more stuff. We're gonna find out how these things hold up. Alright, see you guys later.